Hi, I am Ayan Kumar Bhunia from SketchX Lab of University of Surrey. I'll be presenting our work Text is Text, No Matter What, Unifying Text Recognition Using Knowledge Distillation. Text recognition has been studied extensively in the past 2 decades due to its potential in commercial applications. Traditionally, the field of text recognition remains fragmented, with one side focusing on scene text recognition, STR, and the other on handwriting text recognition, HTR. This, however, is not surprising as STR poses challenges like complex backgrounds, varying fonts, uncontrolled illumination, and other artifacts, whereas HTR tackles handwritten texts where the main challenge lies with the free-flow nature of writing of different individuals. This leads to our motivation: how to design a unified text recognition model that works ubiquitously across both scenarios. Towards our motivation, we had a few observations. The domain discrepancy between HTR and STR can be understood from the observation that a model trained on HTR data and degrades severely on STR scenarios, and vice versa, as shown in the accuracy plot. A naive approach to unify the two scenarios is jointly training a model on both scene and handwritten text data sets. However, due to large domain and model capacity limitations, it still lags significantly behind individual specialized models. Therefore, we introduce a novel knowledge distillation paradigm where a unified student model learns from 2 pre-trained teacher models specialized for STR and HTR. Compared to traditional knowledge distillation, we have 2 pre-trained teacher networks. Given these pre-trained teachers, we aim to learn a single unified student model using a knowledge distillation paradigm. We introduce a character-aligned hint loss to mimic character-specific hidden representations of specialized teacher over the varying sequence of characters. Additionally, an attention distillation loss complements the character-localized hint loss. We also introduce an affinity distillation loss to capture the interactions between every pair of positions of the variable character length sequence. The logits distillation loss is an extension of the traditional knowledge distillation loss for our sequence recognition task by aggregating cross-entropy loss over the sequence. A character-localized hint loss aids in enriching the localized information, by performing feature distillation at the space of character-localized visual features. While attention distillation loss works as a complement to the character-localized hint loss. Affinity distillation loss is introduced to model long-range non-local dependencies from the specialized teachers. Apart from the 4 distillation losses in order to learn from the specialized teacher, the unified student model is trained from ground truth label. Finally, these losses are combined to obtain our optimization procedure. Training paradigm for STR involves using large synthetic datasets such as Synth90K and SynthText and evaluating on real images such as IIIT5K words, SVT, SVT perspective, ICDAR 2013, ICDAR 2015, and Qt80. In context of HTR, we use 2 large standard datasets IM and RIMES. We use word recognition accuracy as our evaluation metric. As there has been no prior work dealing with the objective of unifying STR and HTR models into a single model, we design a few strong baselines based on multitask joint training, unsupervised and supervised domain adaptation, and domain generalization. Empirical evaluation suggests our knowledge distillation-based unifying approach for multi-scenario text recognition to outperform all other baselines and state-of-the-arts by a significant margin. We perform ablative studies to judge the contribution of model components. Figure shows that while discrepancy exists for cross-dataset scenarios, attention maps from unified model is nearly consistent with that of respective specialized model. Table confirms each loss component to be significant towards achieving high accuracy. We also compared the time and space complexities with alternative approaches such as joint training, MTT, a binary classifier followed by specialized domain-specific model represented as BCR, and 2 other naive distillation approaches. Thank you for your attention.